No, thank you. My name is Trevor Linton. You'll have to give me a recovery from a cold a little bit right now. I work for a company, OC Tanner, up in Salt Lake City. We're not known as a technology company, but believe it or not, we have a technology system that supports about 9 million users. To kind of support our staff and a lot of other reasons, we developed a thing called Akkeris. Does anybody know what Akkeris means? I'm just going to give somebody like brownie points if they do know. It'd be awesome. And you can't, where is she? Kubernetes is Greek for captain, pilot, helmsman. Akkeris is Old Norse for anchor. Before I start out, I want to point out that I'm a voice. I'm not the thing that created all of this. These are the primary maintainers of it, and as well as OC Tanner, who funds it and is backing it. And I just want to say thanks. You know, they're nice people. They let us build a lot of really cool stuff. You know, find that a lot. This is also like one of those plugs that is, if you like doing really cool things, maybe you should apply at OC Tanner. Maybe. Anyway, so on to the talk. So why did we develop Akkeris? I personally, I love using Kubernetes, but it is such a pain in the butt. It's by far one of the most difficult technologies to try to train a new engineer or a DevOps or an operations person on. Aside from like the lingo and the changes in kind of what you would normally understand, it's a very difficult system to kind of get your hands around. On the other side of it though, Kubernetes is a beautiful way of orchestrating and running Docker images. So we have this kind of juxtaposition at OC Tanner of how do you manage the two relationships with engineers or DevOps, as well as kind of the need to push the envelope further and use something as flexible as Kubernetes. So the why Akkeris, what's the point here is we found that giving our engineers Kubernetes access was a bad idea. We got to play around with it for a sec and determined that was not a very good way to go. And this was also, what, 2 years ago? 2 years ago. So, you know, before anybody gets into the semantics of whether or not that's true now, I would say 2 years ago was painfully true. So why Akkeris? We, like a lot of other companies, had a big split between our engineering and our operations divisions. Even if you account for DevOps, most of our operations division wasn't in the business of innovations at the company. And that's kind of a dangerous place to sit yourself, if you think about it. That's the place where you get laid off first. That's the place where you're marked as a cost center. That's the place where you aren't considered anything needed. So what we wanted to try to do is be kind of it to the punch, so to speak, by getting into the innovation business and by trying to do things faster than our engineers could by providing the infrastructure for them. So why Akkeris again? I actually came from an engineering background. Of the people on the team that I showed earlier, I'm probably the most engineering. I've been in the industry doing both front-end and back-end development for about 20 years. So I joined the operations team under Murray back there, who's probably glaring at me saying, don't say anything bad. But one of the things that I brought to the team was kind of the voice of the customer saying, there needs to be more ability for engineers to have control and visibility into what's going on. That, you know, InfoSec compliance, you know, your ISO 9660 and your SOC 2 and your PCI are all going to say, that's cool. There's got to be a way of doing that and providing a good engineering experience. Our other goal, as an operations team, we hate talking to people. Engineers and being what we would call drive-bys, where people would suddenly come to your desk and say, I need an entire Kafka cluster by 2 p.m. Okay. It might cost a lot of money. that might also have like a lot of problems and setup. And if you don't use it, then I've got to maintain it. So what is the benefit here? And like, why didn't you talk to me in the first place before you came? Anyway, getting out of the like coupling of having to go to meetings and having to align your interests together is actually incredibly valuable to a business. It doesn't seem obvious on the surface, but the more you can decouple your own individual departments, the faster everybody can move independently. As much as I want to rag on engineers, our true goal is engineer happiness. And actually the second one, through operation simplification, engineer happiness. Our real goal though, and what we actually use as a driving ROI is, can we improve year over year 1% effectiveness of engineers? Can we make them move faster and deploy faster and do things faster? If I can bring OC Tanner one more employee every year by doing nothing other than providing efficiencies, they will return that back to our operations group over and over and over again. And that's something that we can measure, and that's something that we can prove, and that's something that responds well when I was talking about getting out of the business of being a cost center and into the business of being an innovation center. It's hugely valuable for operations to start being perceived that way. And what's our alternative goals? Well, when we were developing this, we wanted to get rid of a lot of the bad practices. So if you want a nut and bolts of what this talk is about, we built Heroku without Heroku. We built basically an open source version of Cloud Foundry that's a little bit better in my opinion. But what we really did in our goal was to take Kubernetes and build something that was very flexible, very unique, and very capable, that also pulled out a lot of the bad practices of like sticky sessions, writing to the file system, using logs.
Are you saying Akkeris is like
Pretty much. So we follow the 12factor.net. If anybody's not familiar, 12factor is basically a bunch of people got together and said, what is the worst things about app development? And they laid out 12 factors, and one of them was, file systems suck. Sticky sessions are the worst. They require so much effort on your load balancer, and in addition, they make deployments so flaky. So they came up with a list and said, like, these are the things that we really want people to focus on. Getting rid of, that is. So we adopted those into the platform. One of the questions we always get is like, when we talk to people about Akkeris is, that's great, OC Tanner's a small company, doesn't scale. As I was saying earlier, I don't think people understand that OC Tanner's been around for a very long time, and they actually do have a lot of entrenched over 25 years of technology. Our systems are used by 9 million users. We have about 123 engineers who use Akkeris on a day-to-day basis to deploy apps. We get 20 deployments a day. We have 200 apps in production on Kubernetes and 765 applications, roughly 800 if you take the ones that have been scaled down because they're not really working, applications. So I don't know if this works for you, it works for us. I don't know what scale means, I guess, but this works. It's not a perfect solution, and it's not something I would say everybody should use. We have a team at OC Tanner who wanted us to try to put SAP on top of it. We just looked at them bizarrely like, that's not an appropriate use case. It doesn't work for a lot of use cases, so don't think that this is like a silver bullet. When does it work? When you have a large variety of apps, languages, and engineers to manage. And you mostly adhere to 12-factor principles. You don't have a lot of sticky session apps. You don't have apps that rely on file systems heavily, or can at least be ported out of it. If you already have something that works, keep it. Nobody's trying to tell you to move it. If it works, keep doing it. If you have compliance problems up to the wazoo where your InfoSec doesn't even allow engineers to touch anything, like, for example, if you're Bank of America, don't use it. If you generally dislike engineers and you just don't want to deal with them, probably shouldn't use it either. They can be the worst. So with that said, What we ended up building on top of it was a set of APIs, a set of brokers, a set of CLI tooling, as well as a UI. If anybody's familiar with the now defunct DS project, it's more or less like that, but we've carried it forward. It's not a port of that; it's written from scratch, but it's something that OC Tanner is supporting. So I'm pretty much going to walk through these features one by one, and if these are kind of meandering or getting boring, you can tell me to stop or ask questions or interrupt me. I really don't mind either way. So the first part of this we'll look at is app creation. So how does somebody in Akkeris get started? Well, there's an NPM plugin. So you guys can actually all do this if you do NPM install Akkeris. This will complain that I've already installed it, but this is how all of our devs get started, by the way. And then you have on your command line a tool called AKA. When you first use it, I'm already logged in, but when you first use it, it'll ask you for your authentication mechanism and a domain that it gets to resolve to. Long story short is that ends up being the way that it gets like an auth token and is able to communicate with stuff. So these are all the apps that we have at OC Tanner. So if I do an AKA apps, it shows me everything that's running. And if I want to create an app, I can create one called Fugazi. Oh yeah, I better give it a work. So now it's created fugazi.alamoapp.octanner.io. This is just the domain name that it defaults to. It's a pretty run-of-the-mill process. At this point, we can deploy a Docker image to it. I should have been prepared for this. Just create docker.io, Akkeris. Is it like hello world latest or something? I forget. Does anybody have a fun Docker image they want me to deploy? No? Seem very sure of yourself, which makes me very unsure of you. Okay, let's try this. Well, okay, what was it? Sorry. Oh, cube-decon? And then latest? And we'll deploy that to our Fugazi app. Go ahead and tail the logs off and see what it's doing. So it's pulling down the image. It's going ahead and tag it and put it into a registry that we manage. It's private to us so that we can do security scans and stop images if they have vulnerabilities or certain things that we don't want. Then it creates it. What?
Is it all open source?
Yep.
Is there any showing?
No. I mean, we use Quay. We pay for Quay, but you can easily use a Docker registry, just an out-of-the-box Docker registry.
It does listen on.
Okay. So which port does it listen on?
2015.
2015. Oh, it's right there.
That's the.
So we can tell it, we're going to take the web Dino, and I'll explain what the hell that means. And we'll take the app, and you might recognize the space, and we'll say, open up port 2015, and it'll say, okay. We'll watch to make sure it stands up again. So it says it stood up. Let's see if it actually stood up, though. So I'm not on a private network. You can probably get to this on your phone. Nope. Did I type the port in wrong? 2015. SIG term terminating process. Did I forget something that I needed to add? Let's check to see what this app is doing. Oh, it says it's running. No, it only terminates on SSL, so everything has to come in under a port 443. Does anybody see what I did wrong here? Yes, update port 2015. So that's a default. No. It'll make sure that the port is open just through the default Kubernetes TCP being open. Do what now? No. I'm going to just redeploy your image. My hunch is there's something that we're missing here, but I'm going to continue on. I am kind of curious, though. Oh, wait. Is that the Nginx container? Nope, that's your guy. Is that?
I don't know. So bad.
Yeah, looks healthy. Does it need more memory than 256 megabytes? All right, we'll come back to that in a sec. So, despite what I just showed you, it really does work. If it didn't, I wouldn't have a job. So we have a lot of apps within here, but deploying Docker images directly to an application isn't exactly the best practice in the world. You'll notice that a lot of these have a little kitty cat and then GitHub. It specifies a URL in which you can hook up a repo to deploy on. So if, for example, you had a repo with some code on it, we look for basically the Docker file at the root of it. I probably should have started with like something that was a little bit easier. So we'll create a new repo. We'll call it Fugazi, because you know Fugazi. And generic node server, I guess. A simple web server. Just copy and paste this. I don't care. It's very astute of you. Sure. Why not? Is this a valid Docker file? Is everybody cool with it so far?
/app. Yeah. Like we're curious, and then just do dot.
Like that?
No, you can't do that.
No.
The word durable action.
Oh, really?
Yeah.
Hey, I learn something new every day, right?
And you can just do dot.
Oh.
Yep.
And then command node index. Yeah. I guess I should check to see if this index file is valid. Okay, I'm going to do one thing that'll probably save us in this. I'm going to make sure that this listens to process and the port. So you can change the ports in Akkeris that it listens to, like you can Kubernetes. But we also inject a default port. We create services that say 900 or 9,000 or whatever we want. Then we inject that environment variable into it, like a 12-factor app. We expect that applications will appear on that port. But in special cases, they can change it. Gut push. So, what was that? Index.html.
The code reads index.html. Yeah.
Index.js. I know. Oh, thank you. Thank you for that. So let's go ahead and Fugazi default. You can attach a repo in Akkeris. Trevor Linton, Fugazi. Listen to the master branch. And before I do this, unless I'm going to go generate a personal access token on GitHub and specify that in the command line, I have to come in here and give it access to overbot, which is our it's our friendly little bot at OCTAN. And if we don't specify I'm just screwing up like royally today. Trevor Linton, Fugazi. Can I not give him a man? Oh, it wants the bot to give. Okay. So we got to do this under the OC Tanner repo. They're going to enjoy this. Hey, Murray, you're okay with me? I'm just going to go ahead and create a repo in those containers. It's fine, right? Don't be worried about it. Sure, why not? I don't know whose email is hooked up to Overbot, but they just got an invitation to join Trevor Linton. So we'll go ahead and give that admin access, and we'll have to push this back up. And we'll have to fix this code too. So instead of doing that, we'll do just like res.write. Is this valid node? Anyway, hello. Let's just try it. Okay, so live demos suck. Seems like I need to add like a res end or something. It's a node thing, right? There we go. So we're going to add in OC Tanners Fugazi. And we're going to push to upstream. And then we're going to retry this again, as I'm embarrassed that this has already taken this long. Okay, so now our deployment system is looking at this repo for anything to change. I can see. And whenever anything changes in it, it'll automatically kick off the code. So we can go in and modify it. So we'll modify like this. I thought I changed this. I didn't commit it. Yeah, thank you. So now we're watch the logs, and we should see a new build get picked up. So both the app logs, the HTTP logs, as well as the build logs all get forwarded to the same place in Akkeris. But naturally, since live demos never work, also a good point. This is why I should have planned this out. Oh, there it goes. So it's going to pick up the Docker file, basically run the steps in the Docker file, push the image up to our registry, then deploy the code. And that's more or less how you create an app, deploy the app either with a Docker image or you deploy it with, tie it up to some GitHub source code and deploy that. And for our developers, it works pretty well. It's a fairly seamless process that they can go in and arbitrarily create anything. We use the concept of spaces. This might sound very familiar to everybody here. They're just named spaces. All of our developers call them spaces. But it does allow us to group together different applications, and we add one additional thing onto it, which are called compliance tags. So when an engineer creates a space, they have to pick what region they want it in. And then they also have to pick what compliances they want. Do they want it in production? or do they want it in what we call a SOX controlled space, meaning an auditable space? If they put any of those two, it puts new controls into basically the life cycle of an app in addition to what a developer can do and see and control in that environment. So for example, production, it may enforce certain limits or requests that come into Kubernetes, where if it's not a production, it'll be vicious and kill an app that's, you know, acting erroneously. I guess I can't find node index.js. I thought I copied that, didn't I? Let's go to. So just like that? Am I good? What was the FU that gave it away? You guys are so helping me. I am so glad there are technical people in the audience. Otherwise, I would just be floundering through this. So, moral of the story, we're going to do another build and release to hopefully this won't say, you know, index.js didn't exist. Does anybody here have the new MacBook Pro? It's a pile of crap. The keyboard on it, like,
I had one from last year.
if I type the letter U character, it duplicates it every time. So I have to remember to go back. Yeah. Yeah. Okay, I didn't see an error. That didn't mean it was successful. But let's try doing the LMO app.oscanner.io. Oh. Interesting. This is quite interesting. Make sure that other things are running here. Okay, so other things are running. That's good. What am I doing wrong here, Murray? Yeah, the terminal. Okay, let's do this. Fugazi 2. Fugazi 88. I still want to see what this thing is, so I'm going to try to deploy it to Fugazi 88 default. Nope. Oh, I didn't catch the other 8. Of course it doesn't. I gotta wait for it to deploy. So we have a concept of who here is familiar with Heroku? Heroku, or any of the Cloud Foundry kind of toolset or systems, PaaSes. We follow a lot of the same kind of semantics as that. We use the term Dino. A Dino is really just a process that runs You can scale up a process independent of the application, so you can have a worker that runs. These aren't concepts that are familiar in the Kubernetes sense. They're not a container that runs in a pod. They are all their own deployments. So if you have like a web deployment that takes all the traffic on a service port, and if you created a worker, it'll get the same build image, but a different command to start it up. So a lot of the ways that our application developers will use it is they'll create a web dyno to serve some traffic, and if they have some tasks that they have to do on a periodic basis, or they have to listen to a queue and process some stuff, they'll create a different dyno type and a different command and run basically the same image with the same environment on it. Okay, let's see if Fugazi88 wants to work for us. Oh. All right. So if we look at some of our, I'll just use some of the apps that we have in our environment. So this is an example of what we call a formation. So you have one application. If you think of this in the Kubernetes sense, this is the namespace. This is the deployment name. These different dyno types are basically dashes and then appended the name onto the deployment. The webs always get the web traffic coming in from a service. The scheduler, the worker, anybody can create and give a command that they want to run on startup. So this over here are the commands that run basically this dyno, the scheduler type, which probably schedules up a bunch of e-cards to go out. And then the worker probably processes them off of a queue and then sends out the e-cards. But these can all be scaled independently. So you see that you have a bunch of different types here. These aren't, like I said, different containers running in a pod. If somebody makes a change into the Gib application, that image deploys to all those different types at the same time. So it gives them the ability to have one repo that has multiple uses for the same business domain problem, which is a little bit, it sounds really foreign from a Kubernetes sense, but from an application developer sense, it makes perfect sense. I want to deploy one app and I want it to have a worker that goes off and sends emails when something happens. And I want to schedule it, it schedules up stuff. And I want to give API that sits on the internet and does stuff. So kind of the takeaway from this is you can scale up those up and down via the command line, just basically saying, how many instances do I want of the web? Well, I want 5, because that's what I need for my load. You can also change the requests and resources. We do it a bit bizarrely. So we talk about, there's a lot of like Star Trek references throughout all of this. But basically we break it down by different types of Star Trek ships that you can be. So these are the different memory resource limits and CPU resource limits that you will get. And you can specify, I want to be a galaxy, and we set the limit on it to be, 1.5 gigabytes. So when somebody's setting up an app, they can actually specify how much memory resources they want, and we require that. We do default everybody to 256 to try to like poke them to be a little bit more cautious about their memory use.
CPU, you don't specify it.
No, we do on the nodes. So we specify a limit on what we're allowed all of the pods to have cumulatively on the nodes so that we don't kill off our kube proxy. But individually, each of the pods more or less can take up as much CPU as they want and fight over it.
So in your namespace, underneath the namespace resource limits, you're not putting CPU.
I don't believe so. I'm looking at you, Murray.
No, we set aside an amount of CPU. We never actually had a problem with occasionally saying our CPU using is actually.
So, is there CPU on the
Yeah, great.
I don't really
it in a specific secret limiting between like, does that actually do something to secrets? I always assumed that just affected the schedulable amount of CPU. I didn't think it did any actual, like if you do that, but don't set any CPU limits to the pods, I don't think it has the impact, does it? Yeah, but does it actually?
Well, what we've seen is it doesn't actually do anything to limit the pods. It just suddenly taints the node if it exceeds a certain limit and starts evacuating pods off of it if things basically get a little excessive. Well, we do on the nodes, but not on any individual like pods now. We manually ask our developers to go and say like, what scale do you need in there? And they monitor all of that stuff and we give them the tools. One of the kind of hard splits that we try to enforce in the organization is we look after the infrastructure. Your app is your own responsibility. We'll give you all the tools you need. But if you want me to try to figure out at 2 a.m. what your Java process is doing based off of a weird stack trace, I'm not going to be able to figure that out. Like you guys have to manage that your own. So I still want to see what this app does. So I'm going to take a different app and I think it does. I think we just have some like funkiness in our default space. Probably shouldn't be deploying apps there anyway. Which one of these are actually being used? Overbin. Ooh, yeah, I'll replace Overbin. That's our test space, Voltron, yeah. But let's first make sure Overbin is up, and then we'll kill it. You're not going to be upset with that, are you, Murray? You don't like, you don't need that. You don't need it. Come on, baby. But seriously, is this Docker image like something I shouldn't be doing? Oh, okay. He's fine. I already have like 20 of them on there. So wait, is this it? Oh, see, there you go. All right. Okay, there was delay in there. Oh, I don't need the default in default, do I? I forget about that. So yeah. Ooh, I don't want to make my presentation your presentation, sorry.
It's really good.
So add-ons and attachments, none of this really works because developers will come to you and be like, oh, that's amazing. I can deploy an application, but I want to deploy a server and I want to do X, Y, and Z. We thought about doing kind of the Postgres within Kubernetes and then found out that was a really bad idea. So we took that out and put it into brokers, managed brokers through AWS. And we have, through the command line, you can look at all of our services. So a developer can come in and say, okay, what do I need? This is an intermix, if you see the word credentials in here, like right there. Those are shared credentials to a database. We don't ever give our database passwords to anybody. People provision them through these add-ons. So if you go through here, you can select, you can get an Elasticsearch through AWS, and a Memcache, and MongoDB, and MySQL Aurora, a Postgres database. We also have a set of on-premises Postgres databases through Nutanix. We live in a Nutanix cluster through a different broker. Those are for where people need to store PII data. We have compliance issues where clients require us to like actually hold the data physically for some reason. Like that's more secure. We have Redis, S3, all the various stuff. The credentials are kind of interesting because if we have, say, a really large database and we need to rotate a password on it, it becomes really easy for us to know which applications are using it and where it's being used, and to be immediately able to rotate it and restart all of the apps without having to kind of talk to a bunch of people. So that's all of our developers, if they want to provision application, say like the perfdb QA one, and we'll attach it to the Fugazi app. So this is going to go through and it's going to provision basically the set of credentials that it needs. And if we go and look at its config, which is a new concept that I know I haven't talked about, but I'm talking about it in a sec. If you're familiar with the two-factor application, is all configuration has to be defined through environment variables, regardless of what it is. You get one image ever from the build that goes into your dev system. At that point, you can copy that image up once it's passed some what we call like pipeline status check. But you don't get anything, nothing is able to change once it hits that dev environment. You have to go modify something in GitHub. But that's to say, stuff changes in environments, so how do you rectify that? So we allow engineers to go through and set environment variables. In addition, when they provision any add-ons, say if they provision a Postgres database, it injects the database URL into that configuration. The system's also smart enough to look through the logs as well as the information that's coming back from the API to hash result sets that might have sensitive data, like a password, and redact it out. So here you see, it doesn't actually show any of the QA database even. And we can go in and create, say, add-ons, create Postgres. Or I'll do this actually. Services. Each of the services has what's called a plan. So for example, these are our Postgres databases. This basically tells you what type of database you'll get. And this just more or less goes to Amazon SDK APIs and provisions a new database. So we can say add-ons, create PostgreSQL standard one, I guess. We'll put it on a presentation for some reason. So that's going to go ahead and create that. Now if we look at the configuration, you'll see it shows the database URL there. However, the URL also is smart enough to redact the password out of the full URL. Here the engineers can change this information, they just can't see the sensitive information, even if they provided the sensitive information. All of this ends up getting stored in our Vault system. So we heavily rely on Vault from the get-go to store all of this. When we go and do deployments, we fetch all of those secrets from Vault and we put them into the deployment package and set it up. So all of that's kind of managed, audited, and controlled through Vault. And if we need to rotate in credentials, we can go into Vault and rotate and update it and then deploy out the rest of the applications. Now, one thing I should say about the compliance is the default space, namespace, is a production space. So spaces, like I was mentioning earlier, has the same concept of a namespace in Kubernetes, because it is a namespace in Kubernetes. But it also has two different things: compliance tags and well, externally or internally, in addition to what region it's in. We have multiple Kubernetes clusters. You can only have one namespace per Kubernetes cluster in Akkeris. So if you have, say, the default namespace in our US Seattle one, nobody can ever use the default namespace in our Ireland Kubernetes cluster. So when you create a space, you specify what region do I want it in, and any apps, any of the brokers, they all operate within that region. So if I create a Postgres database like I just did, but my app is in Ireland or Australia, it creates a database in our on-premise Postgres system on Ireland, or through RDS and AWS through Ireland. So this kind of gives you a little bit of information. What I wanted to point out, though, is that compliant SOX says this environment has a lot of sensitive information and potentially PII data, or data that needs to be PCI compliant or SOX compliant. Therefore, it starts getting redacted, all these values. If I'm in a non-production space, so like, Voltron's not a production space, is it? No. So if I go and do the same thing of an add-ons create, and I do it to an app in Voltron, which doesn't have any compliances on it, and take a look at that config. I can see the password. And I'm not really panicked because all of this is only available on our VPC and internal network. So you can try to hit any of these databases and you're not going to be able to reach them. But the advantage is when people go to create spaces, they think of it in dev, QA, and prod. Some people think of it in only test and prod. Some other developers think of it as, I'm going to create 10 different spaces because I need that much flexibility. Like I need a demo production space, and I need a production space, then I need like a staging space, but I need a staging space that has production data, and I need a QA space, but I also need a test space that has, I don't know. We literally have some developers that have created 10 spaces. So
let me make sure I understood. So you said that any spaces are unique across all clusters.
Yep.
What was your rationale versus being able to play across multiple, almost similar federated clusters?
We wanted to expose the concept of where something was to a developer on purpose, because if you try to be really transparent or opaque about it, say like you can create an app and just specify what regions you want it in and it'll just magically run there. Nobody considers like whether or not the database they're connecting to is in the US from an app that's all the way in, Ireland, for example. So we wanted people to be very explicit when they create a space, what region is it in? And in addition, we wanted people to start being cognizant of like, how are you going to manage data in between regions? Otherwise, you'll run into a situation where people are connecting to databases that are half a way around the world, and you're getting like, intra-region costs that are through the roof because people didn't realize that this app is running in multiple regions and connecting to this data source over in Salt Lake City. You can also add your own environment variables. So they can. So we enforce on a production space backup retention of 7 days. Some of the functionality, like deleting a database in a production space, we don't allow developers to do. They have to come to anybody in the set department or into the ops. There's some obvious, like, we basically have 2 tiers of non-privileged and then privileged, and then a bunch of in-context permissions to limit what people can do. My attitude is like, we hired really expensive engineers, let them have as much capability as possible because they're expensive. But we do understand that, like, from an InfoSec, we had to like dial certain things back. But we do have this Postgres plugin, which literally I kind of ripped off from Heroku. So thank you, Heroku.
Where is access?
So all of that access is denied based off of LDAP rules. Is that what you're asking? Is what defines it? So we have a set of LDAP groups that say this person is a privileged user versus this person is not a privileged user. One of the components of Akkeris is an LDAP to OAuth 2 or OpenID system, and it just basically translates. It wholesales all of the interactions between Akkeris. So if I go to like auth.octanner.io, I can look at my user profile. And this is a true OpenID system. Any of our developers can come in and they can create a new application. They can register that, create a client ID and secrets, and then they can issue authorization, or not issue authorization tokens, but they can use that to go fetch a developer's profile and their membership roles. So for example, I don't know if this is going to work, but we'll try. All right, well. Dash. Okay. Oh. No, it wasn't quite what I was looking for. When's the accept? Yep. The moral of the story is any of the systems that we have can go look up your membership roles. And if they're not in a role that your LDAP group is defined and you get a set in Akkeris to say these are the privileged users, these are the people who have access to it, it'll go authorize people through LDAP. So you got to put in your username and a password, and it enforces the same security that your AD or your LDAP does. And it'll look up that LDAP group to say, do you have access to the system, and shut you out if you don't. And if you do have elevated access, then you can go in and delete things like production applications and production add-ons and those types of things. And it's enforced on the API, REST API level.
So not necessarily roles for different applications, but you're either privileged or not.
Right. Right.
You can see apps, you see all apps.
Yep.
Spaces.
And you would think that would be really dangerous, right? It turns out it doesn't matter. And what's the most interesting part of it is that, well, you know, from our perspective, what they really cared about was whether or not could you change anything in the system without having collusion. That was the number one thing that every auditor came down to, whether it was PCI or SOX, was can you change something in the system without it being audited? They didn't really care if you could change something. It's fine for people to have permission to do stuff. It's their job. It was whether or not you could do it without being auditable, whether or not you had like a backdoor access or something. Having a shared credential is a good example of having something that's unauditable. I had no idea who made that change to the database and thus gave access to something else. Those types of things are very unauditable and very no-nos in the compliance standards manner. But from the perspective of whether or not people should even have the access to an application, that's more of a business decision. At OC Tanner, they kind of took the policy of like, we'll stop it when it becomes a problem. And we've been doing it for 2 years and haven't had a single problem. So, well, you know, fire the people who you don't trust. Why would you hire them if you don't trust them? So we have two ways of auditing. Is everything that comes through the API logs the user and the request that they made, and everything has to go through the API. There's no other secondary system that you can hit. And there's a, I'm going to show you this. This is kind of obnoxious, but I get kind of giddy about it. We have an entire REST API that's incredibly well documented, and people find this so obnoxious, and I love it. But everything goes through this REST API. Every single call from the CLI has to go through this REST API. And that does all of the auditing, and it sticks into an Elasticsearch as well as it sticks it through a syslog endpoint to a provider that's immutable. So we kick it over via syslog to Papertrail that has a endpoint that we can't modify. So nobody can change the records once it's happened. Which our auditors just go, cool, that's fine. They can trust that nobody can do anything without it being discovered, except for the people who can go behind the API, which is only the people within basically 4 or 5 people in the company. So where was I? Does that answer your question? Sorry, man. I don't know if I like went on a long tangent. Probably did. I do that all the time. Webhooks and plugins. So as we were talking about data management, the CLI tool has a lot of components to it. To make it not exhaustive, we have this concept of plugins where anybody can code a plugin and they can publish it up for other people to use. One of the plugins that we have is Postgres. So our Postgres plugin lets you go in and do things like create backups and snapshots and view the locks on a database. If it's an RDS and not a shared instance or an on-prem instance, you can restart the database even. You can go and say, like, what are the sequential scans on a statistics on a certain table? It gives the developer full control over kind of investigating what the problem is. But it also doesn't overload our CLI, so you can just kind of pick and choose what you want. We have one for almost every add-on, like there's a memcached to pull stats and to flush memcached. There's an alerts plugin that I think Murray and one of our other developers wrote in combination to alert you on Slack or through OpsGenie or through another channel if things become XYZ above a certain level. So engineers can obviously manage their own escalation policies and paths. And plugins have been pretty essential because it's provided kind of a thin thread for all of our engineering staff to get on the same page about things. So if you type like AKA plugins, believe it or not, we, and by we I mean the people in who manage Akkeris at OC Tanner that I showed at the beginning of it, didn't program most of these. These are just engineers who decided, like there's one in here called Genesis, and this automates like the creation of a series of spaces and apps. And the developer wrote it in kind of this, I think it prints out the Zoolander. Anyway, there's a story behind that I won't tell. But you know, you get the Genesis references. It automatically creates a bunch of stuff for you. And different teams will create different plugins for automating certain tasks. If they want to onboard a user, they have their own plugin that'll help create all of the like different random dependencies that they need on their system. And they can use this plugins feature for more than just like a PaaS system. They can use it to kind of help enforce different standards in their teams. Let's see. Do we want to take a break? Maybe do some questions or get some more pizza or run to your car because this is way more boring than you thought it would be. I won't be offended.
I have a question on how you said you want to have a 1% increase. What that means to you, how do you
We do two things. We do measure the amount of releases that we have, but we also have, we do a survey. I think we do it every quarter, but we ended up doing it. This one we just sent out. So there's not a ton of responses on it. But we also ask, like, literally, how happy are you? Are you more productive using this other system? And we kind of closely monitor that and then make decisions on what we need to change in the system and report it up to higher up people so that they can feel good about paying for this whole thing. It's hard to measure, right? I mean, it's always going to be a fuzzy factor, and to be honest, it's meaningless. But the impression that we get and ask engineers in the organization to communicate up to their managers is whether or not they're going faster or not. And overall, the happiness or the thumbs up has been through the roof. We have never met I think there were 2 people in the last survey that said that this tool made their job harder, but everybody else said it made their jobs way easier, which is good for us. Huh? Pizza? Break? Potty break? Keep going? Okay. So we discussed a little bit about the compliance. There's also the syslog endpoint you can ship off who did what and where. Ours ends up looking like this paper trail drain. So this is once again an immutable log that we don't have access to, but it does show like who's doing what in the system, when they did it, and what action they took in it. It's not as detailed, but it is immutable, which is the important part. We have a pseudo non-audit log. I say pseudo because it is immutable because we have access to modify it as an operations group. But you can go in and say like what happened to an app, and it'll tell you who did what on when. Yes. So it'll tell you like config changes or releases or builds, and then you can request different sub information from it, like config change. Okay, I don't know how to use my own system. The ID of the active. So it'll tell you what was the change that the person put in and why they did it. It's basically a whole bunch of information on it. It's boring. It helps check a lot of boxes for people who are in InfoSec. Yeah. That's another way that's like a really painfully easy way to make something immutable is you send out an email of what happens because emails are immutable, it turns out. There's no way you can redact it and say, everybody pull your information back or modify it. Oh, blockchain. We'll add that in the next release.
How about your TLS stuff? I'm curious.
Oh, yeah.
Saw some stuff in there about ordering.
So we also have the concept of sites, routes, and certificates. So in here you can go and create a new site. We use F5, Big IP F5 for our front door. And we don't use the official F5 ingress because when we started this whole thing, building it, it didn't exist. So when you create a site, it literally goes in there and creates an SSL profile, creates the VIP. Well, it doesn't create the VIP, it adds it to an SNI VIP that already exists. It actually goes out to DigiCert and requests a certificate with all the information that it needs, watches it, and when it returns back, installs the certificate on the F5 and does all of that kind of management. So if you create a site that's a domain that we manage, it's more or less, if we have a wildcard on it, it's up immediately. If we don't have a wildcard on it, it depends on whenever our InfoSec department gets around to clicking the approve button on the emails that they get from DigiCert, which may take a day. But as soon as they do, it ends up getting issued and put into our F5, and it's all automated, which is the beautiful part. Is we don't want to talk to people. We don't want to have to manage that. It does have to have that stop of approval. That's what our InfoSec department's for. So they get an email from DigiCert, and if they click approve, it goes up into our F5, and we're happy to host it. And then once a site is established in our system, you can add any app and a route to that app. What that basically means is you may have like, you may have one domain, like we have this domain vision.appreciatehub.com that everybody seems to love. And it has probably a good 40 or 50 APIs in it. These are all individual apps that sit. And traffic coming in on the HTTPS basically hits an I rule that we dynamically update that reforwards traffic down to the specific node port of the app that's running. Obviously, this could be easily done with an Nginx like Ingress and some Istio love, which is something that we do want to add, but we have the F5, so I don't use it. which is what we're doing right now. So this is, even though it says it's like routing this site to this other site, what it's really doing is it's taking this site and routing it via an F5 pool to a node port where, say, this management dashboard GWP PRD. This is the deployment. That's the namespace. It has a service with the same name and in the same namespace with port open on a node port that we grab, create a pool in F5 and forward traffic on. What's nice, though, is we also create a bunch of logs and forward those into a Kafka stream that goes into the same stream of data that all of the app logs from Kubernetes go into and all the build logs. So any of our developers can go in and say, I want to view the logs for like our production website, one of our production websites. So these are actually the live logs coming off of our production website that's going from, the F5 is generating the log, it's going into Kafka, and then we have another app that sits there, and when you want to know about logs, it picks up a stream off of Kafka and then pushes it to your CLI. And like you saw earlier, when I did this command on an app and it showed the build and the app logs, it's picking up the stuff it's coming off of Kubernetes and stuff that's coming off of Docker builds, and it's all going into one central source. And that actually leads me into drains. So drains are a concept of, you have all these logs that are sitting up in this, you can just pretend they're in my hands, sitting up there. So how do you persist them to anything? Drains are a concept of taking logs by an app or a site, and you can forward them to any syslog endpoint that you want, or HTTPS endpoint, and it'll just batch them up and buffer them up and put them as a big post if you give it an HTTPS endpoint. We support TLS over syslog, and then just basic syslog over TCP, and then syslog over UDP. Although I think because of our firewall rules, you really can only reach paper trail outside of our own network. Oh, really? Huh. You sure? All right, anyway. That's not the point. I'm going off on tangents. I should probably relax. So for example, this app called API Default, which is the controller app that kind of helps manage some of the parts of Akkeris, it forwards all of its logs to this syslog over TLS to Papertrail. And we actually have Papertrail as an add-on because we have a corporate account with them. And if somebody wants to go in and add Papertrail to their app, they add an add-on. They don't even need to add a drain. And it dynamically generates the syslog endpoint on Papertrail and then injects that into the drains. So all of their app logs will go to a searchable interface on Papertrail. So now we have like Papertrail where we have all of the applications and all of the metrics that anybody could want. Where they can go basically inspect anything they need to. And it persists for 2 weeks.
So your metrics and logs in combination?
No, so our metrics, all of our metrics off of either requests, responses, status codes, memory, we use a combination of InfluxDB and Prometheus. So all of our kind of standard run-of-the-mill Kubernetes stuff comes off of a Prometheus endpoint. And then we also have basically InfluxDB where we forward custom metrics. We do one little magic thing where if a developer formats things into a specific, pick that up and we tag it with their app name and whatever metric name and value, and we put it into InfluxDB for them. So this allows them to put out a bunch of like custom metrics. If they want to track their JVM heap size, they can output that periodically, and it'll automatically go into this InfluxDB system. And then we have a tool, we have Grafana, but we call it membanks. Get it? Star Trek reference? Nobody? Yeah. I feel like that should kill here. Yeah.
You're not using it like again, using a special format.
So we provide an out-of-the-box way of doing it for cheap by You can go into Grafana and graph your own custom metrics if you want. So we do have some team members that use Grafana. Like, we don't limit that in any way, because Grafana, or not Grafana, New Relic or AppDynamics, if they need logs, they all take a syslog endpoint or an HTTPS endpoint as an endpoint. They can add that to their app so that all their logs get streamed to New Relic or AppDynamic or whatever they want. And then they can obviously put in their own agents into the Docker file so that it loads up while it runs and reports other stuff.
What are you doing to the custom logging?
So right now we just have a daemon set of FluentD that kicks it with a Kafka buffered output plugin, pushes it into Kafka, and we just pick those up on Kafka with a tool we wrote called the log shuttle to pick those up and stream it to one place and the next place. So FluentD, yeah. So it just runs with elevated permissions to look at var log containers, so it can pick up all the app logs from that. And then we just manually kick all the logs coming off of our F5 ingress into Kafka as well, in addition to Jenkins, which we use for the Docker builds. I don't know what that, okay. So like, here we have basically our dashboard, and we can go into, each team can create their own dashboards. And so for example, these e-cards given is a custom metric that they basically created a tag. I'm trying to figure out the format of it so I can kind of make this real life for you. It's a little bit hard to see here. Collecting metrics. So yeah, you basically say your type and then the metric name and the value. And you can be either, the type can be measure, sample, or count. And then the metric name is whatever you want to name the metric. And then obviously the value is the value. So for example, in here, one of our apps is you can send e-cards because that's cool. But the tag is prd.victories.recognition.ecard.given. And they admit that into their log equal, and then some count of how many e-cards have been sent, and it goes and slurps up all of that and puts it into InfluxDB, and then they can come in here and graph it out. But we do have team members that just look at us and go, we're just going to use like New Relic, and screw you guys. That's fine. I don't care. Use whatever you want. It's kind of the gimme of it, though. So back to the sites and routes. I think I kind of, so everybody kind of understand that concept of what I mean by sites and routes. Like, you can create a website as more or less a reverse proxy that you map back to different apps behind it. You can make one website host a bunch of different apps. It's just a reverse proxy. Yeah, it's the same thing you would do if you like fanned out on an ingress. It's more or less the same thing.
Do you have practice?
We try to stay out of that business. So those architectural decisions, some teams have different opinions on how they want it to work, and it becomes a little bit of a political struggle to interject yourself in between multiple different teams who want different things. So our attitude is give them the tools, give them controls that are blessed by InfoSec, and let them do any madness that they want, and then we'll go around shutting things down periodically that people just spun up for fun. But it's honestly, it hasn't been that big of an issue, and I think it really does provide a lot of capabilities for engineers to really move fast without breaking things, because we don't want to break things. Facebook, I don't know what, that's the stupidest thing I've ever heard. Move fast and break things. Why don't you move fast and not break things? Yeah.
For service, are you doing like health checks and services as well, or is whatever Kubernetes is running very hard? Are you having service checks as you
So our F5 does a pull check on it every 5 seconds, which basically opens up a TCP connection, says nothing, and closes it. So that might be a good idea, might not be. We're still scratching our head on that one. But we also have the Kubernetes endpoint that's obviously checking the at a pod level to whether or not the pod is up and running. So there's both a service level check and then the pod check that Kubernetes does.
And where your HTTP ties in, is that
The AKA can, what about it?
yeah, so that, where does it point out? Is that storing all that into something different based on?
So that is the user-defined that's a loaded question. The user-defined configuration values are stored in a database in a region API. The service level environment variables, like for a database, for example, like a Postgres RDS instance, are stored with Amazon or with Broker. And the credentials or sensitive information and those passwords are stored in Vault. And so the regional API goes and grabs all of those at deployment time, bundles them up into a config set, or I guess we could do a secret, and then kicks it up to Kubernetes as a deployment. So when you see those coming back the other way, it's just bundling those up, redacting a bunch of things that it doesn't think you should see, and sending it to the CLI instead. Because if you looked at that, if you literally looked at these, like, this will feel a bit more at home for everybody. Is it Orbit Bin, Ultron? Yeah, so you just see it has like the exact same environment variables set that you'd see out of the CLI. It just does it at deployment time.
So you're not using the big maps secret.
We are for some things, but I think overall, not really. We don't let anybody have access to Kubernetes directly. Really,
So,
like,
so the app
ever.
has to restart if you want to grab any new environment.
Yeah. So if you want anytime you change any of the environment variables, it causes a redeployment of an app, basically. Which isn't a bad thing in my opinion. It should be something that's very explicit when there's a change to an application. And it should be very well noted in kind of some system that this thing happened, instead of it being implicitly picking up a change that's happened. So pipelines, regions, and preview apps. This is I told you earlier that people can create development environments right off of GitHub. What happens after that? Well, we have a concept of pipelines. Pipeline is basically, we have pipelines. We have a set of stages. Pipelines, info. There's actually more stages than this. There's a review, development, staging, and production. You can add one or more apps into any one stage. The image on any one stage can then be promoted to the next stage. And you can establish checks in between stages. Images from moving forward or staying in their environment. So for example, if this is the development environment, you may have like give perf dev in development that has its connection up to GitHub. Code changes in GitHub, deploys on give perf dev. If somebody wants to move it up into our staging or production environments, they do pipelines promote from the command line, and it takes the image from dev and moves it up to stage. If they want to do it to stage, they hit the staging button and moves it from stage to production. And that's how applications deploy up into production. In addition to that, the review stage has some interesting aspects that you can create what's called preview apps and enable that on an app. When you create a preview app, I'm going to show you a screenshot of it because it's going to be laborious for me to set up for you. Ah. So if you put in a PR onto GitHub and it has an app that is listening to that GitHub repo, it'll automatically take that app, clone it with the SHA, first 7 letters of the SHA in its name, create an entirely new app, take the source code in your pull request and deploy it onto that preview app, and then send out a bunch of webhooks if tests need to be kicked off, for example. And it adds a little, like, I don't know if you can see it right there, but Overbot deployed. So for the example, in this is the UI namespace, and this is the Sandbox app, and it deployed a new app called Sandbox with the #-UI. It's a way of people getting a preview of what they're about to merge into their development environment. In addition, if it's sitting inside of a site, it automatically creates a new site with all the same routes, but the app that you're deploying or merging into your development gets popped out and your test app gets put in there. So if you need an integrated environment where you have a bunch of apps sitting under one domain, it'll do that for you too. And so that way you can do testing from an integrated perspective as well as directly if it's just one app and directly against that app. It attaches all the same resources that you had on the source app. So if you had a database, if you had a Redis, they both get all of the same credentials. It can be dangerous. You have to know what your app and your purpose is. It obviously doesn't allow preview apps to be created on any sort of production environment, but it's useful for testing and knowing whether or not something is going to break it before you merge the code changes. The REST API, pipelines regions, we kind of talked about. One thing that you should know is that, like, so we have apps that could exist in Ireland, Australia, or the United States. A pipeline can attach multiple apps in multiple regions into a production space. So you can have my app, US Seattle, my app, Ireland, my app, Australia. Those are all in the production pipeline. And when you promote from your dev to your staging into production, it promotes to all 3 of those environments so that you can support multi-regional deployment systems without having to go nuts about it. Finally, just to wrap it up, invoicing and attribution, we don't believe that anybody we believe people should be held responsible for what they do. So we actively produce quotes. Every add-on has a price. Every time somebody creates an app, it has a price. They have to attach it to an organizational group. And then those groups get billed, whether or not you want to actually back bill somebody. We don't do it at OC Tender, but we do have a concept where we send an email to the manager and say, this is how much your team's costing us. So they can look at it and go, oh my, like, I didn't know we did that much in damage. And it really is something where some of our managers have come to us and been like, I didn't realize we were taking up that much resources. What can we do to, like, bring the cost on this down? It's keeping people accountable for it, but not putting barriers in front of them. Some of our engineers even get, like, a little bit skittish when they see prices on it. They're like, I don't think we should spend $400 a month in production. Be like, I think you should. Just do it. It's fine. It's not that big of a deal. So it's good to have people be accountable and aware of what they're costing the organization. The last thing that I'll say before my thing dies here is there's also one last thing. If you don't like the CLI, because most of our engineers don't seem to, we have a UI too. So here you can go in and find the same, like, we'll go, let's look up, what was it, Fugazi? Fugazi default. There's the apps we created earlier. There's the audit log that you can see of what I've done. Shows basically the URL, the image that it's running. If I go in here, I can actually view, like, auditable information of what I changed throughout the talk. You can see the builds and releases from the activity and rollback stuff, or you can see individual build logs that are coming out of Jenkins. There's there's the Dinos that we talked about earlier, where you can change the size of it, the quantity, the port, whether or not you want to put a health check on it. This is all linked up to our OAuth 2 system that, once again, goes through LDAP. You can go in here and provision add-ons, just like we did earlier through the CLI. So we can select, we want a memcache. We want, a large one. And, geez, it's going to cost $135 a month. Never mind. You can attach webhooks to get notified when something changes, a release, a deployment, a crash. Configuration, these are those environment variables. Metrics, this is a simplified view of what you would normally see through Grafana. This just shows basically the same stuff that you would get out of that. Kind of requests, working set. There's not probably enough traffic into this to actually have anything interesting, so I'll try a different app. So we can see the metrics and logs. Do all the sites and routes through the UI as well. You can create routes, create new sites, order TLS certificates. I may have gone the other direction on this. Git has so much metrics, this might not load. Beep, beep. Please. Come on. Yeah, that's too bad. So engineers who hate the CLI, which it turns out there's a few people who do, and a few people who use Windows, which we don't support as much as probably we should. Love the UI because they can use all of the same functionality. And the logs obviously have the same. If you click on that, you're just going to get the immediate live view. No, not loaded. You also get recommendations and warnings. So if it notices that you are using below a certain amount of percentage of your Postgres database, it'll tell you like, hey, you've got a really huge Postgres database attached. If you downsize it, you'll save $40 a month or something. Nobody ever does, but still, it's nice to tell them. So yeah, they get router metrics, and I don't know what this stuff is, a bunch of other custom metrics about mobile client, nomination, give widget, whatever that means. Presentations completed. So these are like the requests, the HTTP requests, and then status codes, and all this is available through Grafana as well. And then if you click on logs, they'll get a live stream of all of the logs coming out of the app. And yeah, you can do the pipelines and deploy, which is probably easier through the UI because you can just click promote. So that's more or less the whole spiel. So upcoming features, we're adding a CI/CD testing component into it so that people can actually write tests and deploy them with their code. This includes pipeline checks, so people can add custom pipeline checks that they want to happen in between promotions. This is so that our change management board can actually approve things through Jira, and it'll automatically promote it in our system without anybody having to do anything. Canary deployments, start routing a certain amount of traffic in, and if it sees an alert go off on that app, flaps everything back. Wider variety of ingresses, we only have F5, and it turns out we don't actually necessarily have to have it. So our new data center we're bringing up in Australia, we're going to do on just a typical ingress on Nginx. Non-AWS brokers, we're starting to embrace trying to build this whole thing out on G-Cloud. And then next after that will be Azure Cert, because our InfoSec won't let us use anything other than DigiCert, and probably shouldn't for the moment. If any of you have paid attention to what's happening with the semantic certs and Rapid Trust and GeoTrust, Rapid SSL, and all those, October 16th is going to be a doomsday. I have the Canary version of Chrome and nothing loads. It's so amazing how many people haven't updated that. Anyway, sidetrack, sorry. So if you do want to get started though, we think that there's a ton here. The problem is we very much married it to AWS and F5. And we want to try to get away from that. So we're trying to open source it. for the greedy position of OC Tanner can't be the single point of failure on this. And from our own management's perspective, they don't have to rely on just, this core 5 people to maintain it. So we want to get other organizations to embrace it and adopt it and use it and to contribute to it. So we are actively looking for people who are interested in contributing, which means you would need to know Kubernetes, you need to have a cloud provider, you would need to have an understanding at least of like Node, a little bit of JavaScript, and a little bit of Golang. We have github.com/Akkeris, where everything is already open source, but it's a big, messy room. Akkeris/Akkeris has a skeleton install. And right now, the skeleton, so this actually shows our cost breakdown. Anyway, probably shouldn't show that. But yeah, we pay about $40,000 a month. And anyway, don't fire me, Murray. So this G Cloud provision currently has more or less a POC, a very, very POC bootstrap, where we're discovering, and my computer's died,